Okay, here we go. This is section 3.3, finite math. And we're going to kind of pick up where we left off last time with our furniture problem. If you remember, we were going to manufacture either chairs or sofas according to the criteria. And before we do, I'm going to point out one thing, and this is the important thing of the lesson. It's called the fundamental theorem of linear programming. And this whole thing as a collectively is called linear programming. And basically it says the maximum, or it could be the minimum, value of the objective function is achieved at one of the vertices of the feasibility set. So when we graph it, it's going to be at one of those points. Okay, now I'm not going to bore you, but here's all the information we had before. And then we came up with the inequalities. Remember, you always have x greater than or equal to 0 and y greater than or equal to 0. And then here we had 6x plus 3y less than or equal to 96, x plus y less than or equal to 18, and 2x plus 6y is less than or equal to 72. Once you had those, then we wanted to graph them, and then I found the x and y intercepts for each of those. And when I flip the page, you'll see the graph. And then this is the profit function. Profit is 80x plus 70y. In all of these problems, you're either going to have a profit function or a cost function. You maximize profit, you minimize cost. And I'm going to show you one problem from each type in this lesson. The maximization is the same thing that what we were working here, so we'll finish that and eventually I'll get to a minimization. Okay, now my graph looks a little funky here, but if you'll remember, we had 5 sides and you have 5 vertices. And you'll see in a second what I did. Each vertex I went ahead and labeled them. And actually I said I called this one point A, and this is point B. There's C, there's D, and there's E. And it really doesn't matter how you label them. I just did that. Actually, I copied from the book, but as it just gives us a way of talking about the points as we go through it. So what I did down here is I took the same picture here and I expanded it a little bit. Makes it easier to see. So when you look at it, here's point A, point B, point C, point D, and point E. What I'm going to need to do is find the coordinates for each of those points. So let's look at point A, which is right here. A is the intersection of this line and this line, which those are the two equations for it. Okay. So, some of my red bled through there. L1 was this line and L2 was that line. So I want to find the intersection of L1 and L2. So I wrote those down here. Now, one way of doing this is to use linear combination. So if I did that, let's say I wanted to get the y's to match up, so the top would stay the same. So essentially I just multiply by 1 to stay the same. But down here, if I want to get the y's to match, I'm going to have to multiply through by 3. So that becomes 3 times x is 3x, and 3 times y is 3y, and 3 times 18 is 54. Those are the same, so we're going to subtract. So 6x minus 3x is 3x. The 3y's drop out. And 96 minus 54 is 42. When you divide by 3, x is equal to 14. Then if you go back and plug in, you can plug in either one. But if I put 14 here for x. 14 plus what number gives you 18? Looks like y is going to be 4. So that would give you the point 14, comma 4. Going back to my picture here, A would have the coordinates of 14, comma 4. Okay, we're just going to work our way around here. Let's find out what B is. B is the intersection of L2 and L3. So, here's L2, here's L3, and it really doesn't matter how you do this. I think I'm going to multiply the top by 6. I'm going to get rid of the y's. So that becomes 6x plus 6y equals, and 6 times 18 is 108. The bottom one, I've already got a 6y, so I'll keep it the same. So essentially I'm multiplying by 1. So that's going to become 2x plus 6y equals 72. Now I've got the 6y's, I'm going to subtract. Remember to always circle that. Otherwise you get in trouble sometimes. 6x minus 2x is 4x. Those guys drop out. And 108 minus 72 is 36. So when you divide by 4, x is equal to 9. If you plug back in, this is the easy one. If x is 9, y's got to be 9. So that's going to give you the point 9, comma 9. Sliding back to my picture, this point here is 9, comma 9. Okay, I'm going to go away from my other notes, but let's talk about point C. Point C is on the y-axis, and the y-axis, x is always 0. It's the intersection of the y-axis and this line here. So if I take that 2x plus 6y, I'm going to just do it over here to the side. I'm going to take 2, and we know x is 0, so I'm going to plug that in. So 2 times 0 plus 6y equals 72. This is 0, so you got 6y equals 72, so it looks like y is going to be 12. So this point C is going to be at 0, comma 12. So when you work around, we've got this point, it's 14, 4. We got this was 9, 9. This one's 0, 12. I've got one down here, but you know what that one is. That one's 0, 0. And the last one is over here at point E. E is on the x-axis, which means y is 0. It's the intersection of the x-axis and this line. So if I take that 6x plus 3y, 6x plus, and in place of y, I know y is 0. So I substitute that in. So this drops out. I get 6x equals 96. It looks like x is equal to 16. And y would be equal to 0. So E is going to be the point 16, comma 0. Okay, so I got 0, 0, 16, 0, 14, 4, 9, 9, and 0, 12. No particular order. And that represents all the, what they call the corners sometimes, or the vertices of that feasibility set right there. Everything inside the polygon. Those are your corners. Okay, now that you have that, okay, so now I have written down my 5 vertices. And then up here is your profit function. We had that way back. So the profit is 80x plus 70y. The fundamental theorem of linear programming says that if it has a maximum or a minimum, it's going to hit at one of those vertices. So all I have to do is take each of these vertices and plug into that that function. So my profit at 14 comma 4 will be 80 times 14 plus 70 times 4. And I had that number. I'll do it the hard way. I'll get my calculator out. We got 80 times 14 plus 70 times 4, and $1,400. 1,400, and that's in dollars because we're talking profit now. So that means if we made 14 chairs and 4 sofas, we're going to make $1,400. Okay, now let's put the next point in. The profit at this point, and that's what we're doing. We're going to find the profit at each one of those points. So that's going to be 80 times 9 and 70 times 9. And that is going to be $1,350. Let's go to the next one. The profit at 0, 12. That's going to be 80 times 0. That's nice. Plus 70 times 12. And that is going to be $840. The next profit, it's going to be 80 times 0, which is 0, plus 70 times 0, which is 0. So this one's just going to be 0. We're not going to make anything, which makes sense. If you're not going to manufacture anything, you can't sell to make a profit. Okay, and then here's the last one. Profit at 16, 0. So that means you're going to take 80 times 16 plus 70 times 0. So 80 times 16 is going to be 1,280. That's $1,280. Okay, we've done all the work. Now we're ready for our answer. Our maximum profit. This is the most amount that you can make. Maximum profit. All we have to do is look at these numbers, say which one is the biggest. 1,400. Don't really need the zeros, but I'll put them there. That's the most you can make. And then let's finish it off. When does that happen? Well, 1,400 is up here. That happened when we were at this point here. That's 14.4. Which means you're going to make 14 chairs and 4 sofas. Now, put yourself in the situation of you know, you're the manufacturer and, you know, they're going to hire somebody like a foreman or somebody like that that needs to make a decision. How many of each one do they need to make to get a maximum profit? The boss wants a maximum profit. How are you going to get it? Well, somebody on staff will go through a process similar to this, and they'll come up and they'll say, well, we need to do 14 chairs and 4 sofas. And then that foreman will go to work and say, okay, how am I going to produce those? And he'll come up with a plan. Okay. Now, that was all the same problem that we did in 3.2. I just spread over 2 sections so you could see the whole thing. Okay, now I've got another one I'm going to put on here. And we're going to, this is a minimization problem. And it's the same what's in the book if you got a book and you want to read it. Now, let me read through it. And it says, example 2, nutrition. Suppose that a person decides to make rice and soybeans part of their staple diet. The object is to design a low-cost diet that provides certain minimum levels of protein, calories, and vitamins, vitamin B2 in particular, which is called riboflavin. And suppose that 1 cup of uncooked rice contains 21 cents and contains 15 grams of, that's supposed to be of, protein, 810 calories, and 1/9 milligram of riboflavin. On the other hand, 1 cup of uncooked soybeans costs 14 cents and contains 22.5 grams of protein, 270 calories, and 1/3 gram of riboflavin. Suppose that the minimum daily requirements are 90 grams of protein, 1,620 calories, and 1 milligram of riboflavin. Okay, so he gave us all the information. Now this is what we're supposed to do. We want to design the lowest cost diet meeting those specifications. In other words, we want to minimize our cost. Okay, so what are we going to do? Well, if you'll remember, I gave you 7 things to do. You want to define your variables, fill in your chart, find your inequalities, find your profit cost function, graph the inequalities, find your vertices, and then plug them in. So this much of it, the first 4 we did in section 3.2, and then these 3 are what's added on, but it's one big long problem. Okay, so let's come up with our variables first. So we're going to have X and we're going to have Y. Okay, so X is, go back up here, I'm going to find, okay, we got rice and we got soybeans. So X would be the amount of rice, I'm just going to put rice, and Y is going to be soybeans. Now we got to come up with a chart. Okay, so this is where it's going to start getting a little hard to understand. Okay. So one of the problems that you're going to have is knowing what goes where. Well, the variables are up here, so we got X and Y. So that is rice and soybeans. And then over here are our, what I call our restrictions. Or limitations. So what goes over here? Well, that goes with these other things. So when it talked about uncooked rice, it costs 21 cents. There's 15 grams of protein. So I'll put 15. I'm just going to go ahead and fill that in. And then calories, I'm just going to put cals. There's 810. And then riboflavin. And it was 1/9. So what I've just done there, I don't know how this is going to show up. I don't know if you could see that, but that's where that came from. And then let's go ahead and put this here. It costs 21 cents. So at the bottom, your cost is 21 cents, which looks like that if you put it down in numbers. Okay, now let's find the next column. That talks about the soybeans. Soybeans costs 14 cents, contain 22.5 grams of protein, 270 calories, and 1/3 gram of riboflavin. So, we'll put this one in first. 14 cents, 22.5 grams of protein, 270 calories, and 1/3 of a gram here. And then the last thing is my minimum daily requirements. Those are my restrictions. I have a minimum. I've got to hit this right here. So this has to be 90. This has to be 1,620. And that's got to be 1. Okay, so now go back to here. We define the variables. We got our chart. So I'm doing it off screen there. Now I want to find the inequalities. Okay, this is easy now that you've seen the process. It's going to be 15x plus 22.5y. And that has to be greater than or equal to 90. Because these are minimums, right? If you look back over here, it said minimum daily. So that means this is a minimum that's going to be greater than or equal to. My second one was going to be 810x plus 270y greater than or equal to 1,620. And then I'm going to have 1/9 x plus 1/3 y greater than or equal to 1. Okay, and don't forget, you're always going to have x greater than or equal to 0 and y greater than or equal to 0. The problem would not make sense if you weren't taking something from each one of those. You would talk about a negative amount. Okay. Now what? Now let's take these equations here. I should say inequalities. I don't like that it's got the decimal. So let's play around with that one. So that's 15x plus 22.5y greater than or equal to 90. I could multiply by 10, but how about we multiply by 2? So 2 times 15 becomes 30. That was x. Plus, and if you take 2 times that 22.5, that's going to be 45y greater than or equal to 180. Now, what I did, I took the equation that was up here, and it was awkward because of decimals, so I took that equation from up there, and I changed it to something with nice whole numbers. Let's do the same thing with the second one, if we can. I guess the second one's okay. I got 810x plus 270y. All I'm doing is copying. Greater than or equal to 1,620. You know what we could do there? See how they all end in a 0? If I divided by 10, or multiply by 1/10, I'm going to have 81x plus 27y greater than or equal to 162. My numbers are a little bit better. And then this last one where I had 1/9 x plus 1/3 y greater than or equal to 1. I'd like to get rid of these fractions, so what would happen if we multiplied through by 9? If I did, that's going to be x plus 9 times 1/3 is going to be 3y greater than or equal to 9. Okay, my attempt there was just to come up with nicer numbers. So let's take those. Let's go back to this, okay? So all I'm doing is copying again. It's awkward because I don't have enough space to do everything I want to do. Okay, so there's the first one. Here's the second one. And here's the third one. Okay. Now, what do I want to do with those? Well, now we're ready to graph. So let's find the x and y intercept for each one of those. The x-intercept here, you got 30x. If I cover that up, x has to be 6. If I did the same thing for the y's, y is going to be 4. Nice numbers. Okay, on this one, if I covered that up, it looks like x is going to be 2 and y is going to be, boy, it'd be real nice if that went in there evenly. Let's just see. 6, how about that? And then the last one, okay, so the x value would be 9 and the y value would be 3. Okay, now what? Well, now we got a graph. Okay, get all my toys out here. So I'm looking, if I look at the x's, okay, so I got to go out to at least 9, and on the y's I got to go at least 6. So here's what I'm going to do, and I'm going to do all of this from scratch. So bear with me. I'm just going to make a grid. I'll make these even. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'll do the same thing going up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I went 10 that direction, and I went 10 this direction. Okay. So going back to my work here. My L1, remember how I told you to label these? So like there's L1, L2, and L3. So if I want to graph L1, I'm going to go 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4. And I'm going to draw a line. And my tick marks, since it's greater than, will all be this direction here. And that's L1. Let's get L2. L2 hit at 2 and 6. X is 2 and Y is 6. There's L2, and the tick marks again are above. Okay, and then L3 hit at X equals 9, which is way over here, and Y is 3, which is right there. And again, your tick marks are up here. Now remember, we got x greater than or equal to 0 and y greater than or equal to 0. Don't forget those. So if x is greater than or equal to 0, that would be everything to the right of the y-axis. And y greater than 0 would be everything above the x-axis. So my intersection would be all of this up here. This is what a minimization problem looks like. Okay, and then I usually, you've seen this before, where I'll make this a little bit darker. So you can see your edges. You got an edge right here. Okay, hopefully that makes it a little bit more dramatic so you can see what we got. Okay, we got a lot of stuff there. I'm going to switch colors real quick. See if this one shows up. Okay, so you can see your edges. I darkened those in. Where are your vertices? Well, I'm going to start up right here. There's one of them. I'm going to call that point A. And if you follow this down, there's a point right there. That's B. And here's C. And there's D. I didn't label it, but that's L3. So we've got to find the coordinates of each of those points. Okay. So let's say we want to find, I'm going to go to black. If I want to find point A, we know that it's on the y-axis, so we automatically know that x equals 0. 0. Don't know why I put 3. That makes sense. X equals 0. And it's on this line here. What line was that? That was L2. L2, if I go back to my notes, was 81x plus 27y equals 162. Remember, we're talking about the line, so we don't really use the less than and greater thans. So if x equals 0, I'm going to put a 0 right here. So it's 81 times 0 plus 27 times y equals 162. If you solve that, y is going to be 6. And we actually knew that because that was an intercept I found a minute ago. Okay, so A is going to be the point 0, 6. I'm going to put that up here. Got to keep organized on this stuff. Okay, let's go to point B. By the way, you're only going to have 4 points. That's a little easier than the last one. Point B is on this line, which is L1, and this line, which is L2. L1, L2. L1 was 30x plus 45y, all I'm doing is copying, equals 180. And L2 was 81x plus 27y equals 162. This is going to be a tough one. We've got to either get the x's to match up or the y's to match up. I just saw something. I'm going to try and make this easier for you. Let's get our numbers better. if you look at this top one here, if you took a 5 out of each one of those, that makes it 6x plus 9y equals 36. And the bottom one, believe it or not, 27 goes into all of those. 27 goes into 81 3 times. And then that's going to be y, and that's going to be 6. Okay, so let's do a little linear combination. I'm just copying again. I keep running out of room. So how about we multiply the bottom by 2? We'll keep the top the same. So that's simply going to be 6x plus 9y equals 36. And the bottom one, if I multiply by 2, you get 6x plus 2y equals 12. I'm looking to see if I made any mistakes here. Because I'm going to get kind of an odd number here. I think I am. Okay, so we're going to subtract because the x's are there. So 9 minus 2, that's 7y equals 24. I don't like that number. So y is going to be 24 over 7. Okay, at this point here, I'm going to cheat and look at the book because if I keep going and I've got a number wrong, and it's a calculation error is what it is. It's a calculation error that just messes everything up. Nope, it's right, 24 over 7. So if I plug that back in, I can plug it in anywhere. Let's put it right here. So 3x plus 24 over 7 equals 6. Let's multiply everything by 7, gives you 21x plus 24 equals 42. So 21x will be equal to 18. X will be equal to 18 over 21, which is 6/7. So that tells us point B is 6 over 7, comma, 24 over 7. You got to make sure you put them in the right place. I almost put them backwards. That's point B. That's an odd one. Point C. Go back to our picture. Here's point C. It's on this line, which is L1, and this line, which is L3. So now I'm going to go back. I'm going to take L1 and L3. So L1, 30x plus 45y equals 180. And L3 was x plus 3y equals 9. Oh, let's see. At one point, I changed that up there. I took 5 out all that, made that 6x plus 9y equals 180. That makes my numbers a little bit better. Okay, let's go with that. So I got 6x plus 9y equals 180. And I've got x plus 3y equals 9. We'll keep the top one the same. 6x plus 9y equals 180. We'll multiply the bottom one by 3. 3x plus 9y equals 27. So when I subtract, I'm going to have 3x, and I got 180 minus 27, and that's 153. So x would be 153 over 3, which just happens to be 51. And if I put 51 here, okay. Feel like I got something wrong again. Simple numbers. We check back. Oh, I didn't divide by 5 here. 6, 9. This is 36. So this is, let's see, that was 36. And I kept that the same, so this is 36. This is 9. 9 over 3, x is 3. And if you put it back in there, y is going to be 2. So that tells you c is going to be the 0.3, 2. So back to my picture. This point is 3, 2. This one was 6/7, 24 over 7. And that leaves this point here, point D. Well, remember on D, y is going to be 0, right? So it's going to be something, 0. And it's also on L3. So if you go back to L3, we'll put it up here. L3 was x plus 3y equals 9. So if I put a 0 in right there, x is equal to 9. So this point is the point 9, 0, which is the same as that intercept I found a few minutes ago. Okay, this is getting a little longer than I wanted it to be, so let's get it finished up. So, my vertices. A was at 0, 6. B was 6/7, 24 over 7. C was at 3, 2. And D was at 9, 0. Okay, let's go back to the chart. My profit function actually is a cost function on this one. My cost function, I'm going back here. You had 21 cents and 14 cents. So that's going to be 0.21x plus 0.14y. If you just want to use 21 and 40 and 14, that's fine. Just remember, this is cents. We got to change it back. So my cost here will be, I'm just going to put 21 times 0 plus 14 times 6. So that's 0. That's going to be 84. So that's going to be, okay, now I'm going to put that back in. It's going to be 0.84. 84 cents. Okay, my cost here is going to be 21. I'm going to keep this, okay, I got 6 over 7, and I got 14 times 24 over 7. Just plugging the numbers in. So that's going to be 18 plus 48. 18 plus 48 is going to be 66 cents. 0.66. Okay, my cost here, I'm going to take 21 times 3 plus 14 times 2. Numbers are a lot easier here. 63 plus 28, looks like that's going to be 91 cents. And my last one, my cost will be 21 times 9 plus 14 times 0. So that's 0. This is going to be 189. That's $1.89. Ran out of room. $1.89. Okay, now what are we trying to find here? We want to find the minimum cost. All we got to do is look at our numbers. I got 84 cents, 66 cents, 91 cents, and $1.89. What's the smallest number? 66. So my minimum cost is 66 cents at, 66 happened at, wow, 6/7 and 24/7. So that means we want 6/7 cup of, what was it, rice, and 24/7, that's 3 3/7 cups of soybean. And that's how you do that. It's a long process. It takes a good while to do it, and you got to be organized. And I apologize because, I mean, if I did a really good graph and all of that and tried to fit it on the paper, you'd never be able to see it. So I tried to spread it out a little bit. But it's the same things, okay? Define your variables, step 1. Step 2, come up with your chart. Step 3, get your inequalities. And you can get your profit or cost function if you want to do it there. Step 4, graph it. Step 5, determine where your feasibility region is and come up with your corners or your vertices. Next step, take those vertices, plug them into your profit or cost function, depending on the problem, and then come up with the answer. It's a long process, but it works. Okay, and with that, I am going to stop. You know, maybe I won't stop. I want to show you one more thing. Let's go back. This is an alternative method. You may like this better. I don't really care. Let's say I'm going back to this point B. We're trying to find B. And B, I'm just going to go ahead and jump. And let's say we had 6x plus 9y equals 36. And we had 3x plus y equals 6. Now, I use linear combination, but like this equation, you could say that's y equals negative 3x plus 6. And on this one, if I took this equation, I'd be 9y equals negative 6x plus 36. And if you divide it by 9y equals, that's going to be negative 2/3 x plus 4. So look at these two equations. I got a y equals and a y equals. Remember doing that back in chapter 2? Actually, it's chapter 1. So instead of linear combination, you could set those equal to each other. You could take your negative 3x plus 6, set that equal to negative 2/3 x plus 4. Okay, so let's take, I'm going to add 3x over here. So that's like 9/3 plus negative 2/3. That's going to be 7/3 x. And I'm going to subtract the 4 over here, so that's 2. And if I cross multiply or whatever you want to do, I'm going to get 6/7. That's equal to x. And that's what I had before, 6/7. If you like doing that better, using that y equals method, that's fine. And you will see it in the book. Matter of fact, the book probably does it more than I would. I tend to like linear combination because as the numbers get harder, the y equals method is not a very good method of doing it. Okay, now I'm going to be finished. That should give you enough to get busy on section 3.3, and we'll see you next time.